Hello and welcome everyone to another session on exploring GitLab for machine learning and data science use cases. Today we're continuing our path on exploring GitLab pipelines for hyperparameter optimization. And this time we're gonna do the simplest hyperparameter optimization pipeline. Just going back a bit, why are we doing this? Hyperparameter optimization is a very tedious, long process within machine learning lifecycle. It's about choosing the best parameters configuration for your algorithm and for your data transformations. But they can give some really nice results in the end. They can increase your performance quite a lot. But for that you need to run a lot of models, a lot of training. So it's the perfect candidate for a CI/CD pipeline. It's also the first step towards AutoML. So if you think that the algorithm that you choose in itself is a hyperparameter, you can think as AutoML as an extension of hyperparameter tuning. And within this, is GitLab CI a good tool for this use case? It makes sense within the GitLab ecosystem, but is it the tool that we currently have ready for this? So if you want to follow up, this is just a part one. I have a summary of everything on the hyperparameter exploration epic. And I recently published the part 0 of this. If you don't know what hyperparameter optimization is, you might want to check out. It's just an explanation of the concepts behind hyperparameter optimization. So, what are we going to do today? We're going to create kind of the hello world of this. So we are building up here the foundations of what we're going to work on the next few parts. So just the most basic hyperparameter optimization pipeline we can think of. So we're going to use synthetic data that is small. We're going to have a very simple model. We're going to use the simplest hyperparameter optimization that we can think. It's going to be not going to be parallelized. It's just going to go serialized one after the other. We're going to just have a few number of parameters, and the results are going to be posted directly into the MR. So no external tools, no model registry for comparison, no hyperopt, no Bayesian approach, no parallelization, nothing like that. That will come soon, but it's nice to build upon. So without further ado, let's see it in action. So I have this over here. So suppose I have this repository which I'm using for this code. So I have, for example, I have a simple model that runs. I'll go through the code later. But what is important at this point is that I have these hyperparameters over here. And I have created a GitLab pipeline over here that will run the optimization whenever a new merge request is created. So let's say I want to create I'm going to come over here with the hyperparameters. And then I'm going to edit this. I'm going to say, okay, I want to test an additional hyperparameter over here, or value for the mean sample split, which will be 30. It doesn't really matter. So I can create a new branch, with new parameters, which will start a new merge request. So I can just I could write a nice message, but I won't do this right now. So if I look over here, it's checking. Let me just refresh the page. Okay, so the pipeline is already running over here. So it's very simple. We're going to explain. This can take a while until the Docker is executed. I'm going to speed up this so you don't get bored. And so you can see here now already that it already installed all the packages that we need, everything that was defined on the requirements.txt. It's just installing, and now you can already see here that it's already generating the data, and soon it's going to start the training. It doesn't generate the output as it goes. When it finishes the script, it generates the entire output. Okay, so now we can see that it generated all the trainings. So 5 training models for each combination that we have, each one taking 1 second. So it was about it trained the model 90 different times. Yeah, and then formatted the results and then published to the MR. So now we can go back into the MR that I just created, and that's not it, that's this one. And then we can see that it actually generates a comment into the MR with the best accuracy and the table of the parameters and the results. So you can see that the difference between the worst and the best cases is about almost 0.1%, 1.5. So that is actually quite big. So if you think here, it's not, but if you're running a multi-million dollar company revenue and you can increase your revenue by 1.5%, that's quite a lot. So yeah, so this is the simplest thing we can do. And now I can go a bit over the code in itself. So very simple. This is a very simple pipeline. I start by generating a fake data. So instead of using a real data or some of the data sets out there, what I do, I generate 7 different variables randomly, and then I create a function y that is true or false depending on this equation that I don't know, typed randomly. But the fact is that y is either true or false in the end. So this is a classification problem, and y is completely determined by those variables. And then what I do is that I remove 2 of those variables. So 3 actually of those variables. So instead of having 7 variables for prediction, I only have 4. This means I don't have the entire information available to me, which makes it cool for machine learning. we can use the data to try to recover the actual y. Then I run the optimize SKLearn script, which is also very simple. It trains the model, which is a random forest classifier with specific random state just to define, and it uses the GridSearchCV from SKLearn to optimize the data, the hyperparameters. It's a very simple algorithm. It's just try all combinations available. So if you have 3 parameters, each one with 3 different values, or in this case we have 3, one with 3 parameters, other 2, another 2, that means we have 12 combinations. Then we will try 5 times each one of these combinations. So it loads these hyperparameters from the hyperparameter file that I just showed before, and you can configure very easily, very quickly, and it passes directly into the optimizer. Then a very simple script into that does the formatting, so it picks up the results, the CSV results, transforms into Markdown, and then a final one that just publishes this to the MR. So instead of this is not related to this project in itself, this can be used in any project you have. It just passes down and sends a message into the MR. So this was a very simple example. It's the start of our exploration, but we can already see some really good important points over here. And I think the biggest pain point for myself is that the iteration speed of changing the code, committing them, testing on the GitLab UI, checking again, waiting for the GitLab pipeline to run, checking, changing again, and this whole cycle takes a really long time. And it could be a lot faster if it ran locally. It does. We do have some tools like the pipeline editor and the GitLab validation from on the VS Code marketplace, which help a lot. But the fact that you need to the problem is that you need to test them, the thing running, and it just runs on GitLab UI. It doesn't run locally. There's no solution for running them locally, so that's very unfortunate. Up next, we the part 2 of this is trying to make it parallel. So if you saw before, it just runs a single pipeline. It doesn't parallelize the runs, which is not optimal. In this case, it's not a problem because each run takes 1 second to finish. But imagine that you have it takes 5-6 hours to train a model, which is not unreasonable. It's common to have this kind of application where it takes 6-5 hours, days, weeks sometimes to train. So making it parallel is quite important, and this is what we're gonna do on the next session. And then the part 3, a little bit going beyond, is instead of using this predetermined approaches where you have every single combination already stored or computed from the get-go, we use a little bit more of the iterative algorithms that update the possible values every iteration. So this is what we will be working on soon. Parallel to this, we are also integrating this with an ML flow, so keep an eye on it. I will share the link as soon as I have it. But yeah, thank you for watching and see you next time.